I am Alex Janelle C. Brigman, and I am here to present Isometries of the Plane to give you more information about it and to give some examples so that we can understand it more. First, what is isometry? Isometry is the process of moving a geometric object from one place to another without changing its size or shape. There will be more examples for this for further understanding. There are types of isometries. First is translation, next the reflection, and third is the rotation. First, translation, also known as slide. As you can see in this slide, the picture is a slide, as it is also known as like that. Translation moves every point in the plane of a fixed distance in a fixed direction. Here, as you can see, the thumb, it was just slide. That is the example of translation. That's all. Next will be the reflection. It was also called as flip. Moves an object into a new position that is a mirror image of the original position. The best example for this is the mirror. Reflection itself, it's all about what you see, what you see. The mirror in a line called the axis of reflection. Here, this one, that is the mirror line, also called as the axis of reflection. Also, for the previous slide about translation, the movement for this translation is just either up, down, or sideways or diagonally, just like this. The next is the rotation. It is also called the stern from the word itself rotate. Keeps one point fixed and moves all other points in certain angle relative to the fixed point. So just like this letter F, it was rotated like this. It becomes like this pattern. Our rotation preserves orientation. Everything rotates by the same angle in the same direction, so left stays left and right stays right. Nothing changes here, it's just the position. It will just rotate, and it will be rotated at an exact angle. If you want 95 degrees, 80 degrees, 180 degrees, or 365 degrees, you can do it. Next is the dilation. This is um also part of the isometries, but here it is a bit different from reflection, rotation, and translation. Because as I said earlier, I mean, that isometry is about moving a place to another without changing its size or object. But here, dilation, as you can see in the example, the drawing, if it became dilated, it was big. It is a bit different from reflection, orientation, and translation, obviously. It changes the size but somehow preserves the object. Of course, the look of the object is the same, but the size is different. The secret here is either enlarging or shrinking of the object, just like the example here. Then lastly is the multiplication table of isometries. As you can see, there is a reflection, translation, rotation, and glide reflection. The reflection here, translation here, rotation, and glide reflection also. It was the same, like this and like this. So reflection and reflection, it will be either translation or rotation. Reflection and translation, it will result in glide reflection. Reflection and rotation also result in glide reflection. Reflection and glide reflection, it will result in translator rotation also. For translation and reflection, it will result in glide reflection. For translation, of course, it will be translation. Translation and rotation, it will be rotation. Translation and glide reflection, reflection or glide reflection. Rotation and reflection, glide reflection. Rotation and translation, it will result to rotation. Rotation and rotation, of course, it will be rotation or translation. Rotation and glide reflection, it will result in glide reflection. Lastly, for glide reflection and reflection, it will result in translation or rotation. Glide reflection and translation, rotation or glide reflection. Glide reflection or rotation, it will result in glide reflection. Glide reflection and glide reflection will result in translation or rotation. This table is a constant, so you just need to follow this multiplication table of isometries. And that's all. Thank you.